So here we have a conditional probability problem. How do we know it's a conditional probability problem? Well, this is of a fairly standard structure, this question. You've got a number of pieces of an object, there's two different types of it, and you're going to draw them at random. It mentions probability in the question, but a tree diagram is necessary because of this fact that two pieces of fruit are going to be drawn. So, because we don't know what's going to happen first, that's going to affect the probabilities of what happens when we take the second piece of fruit. So, just draw a tree. I mean, starting with that is a really good idea, and it's going to be orange or an apple that comes out each time, so O and A, O and A, O and A. Now we have n pieces of fruit to begin with, and 4 of them are oranges. So what's the probability of the first one being an orange that you draw? Well, 4 out of n, so 4 over n. How many apples are we starting with? Well, if there's n pieces of fruit and 4 of them are oranges, then n minus 4 must be apples. In other words, the probability of drawing an apple would be n minus 4 out of n. So we can fill in those two probabilities to begin with. Now before we go on and fill in the whole rest of the probability tree, it's worth just asking yourself whether we need the whole thing. So really, everything I've done so far is reading up to kind of this point here. If we read this next line here, we're told this very odd information that once 2 pieces of fruit have been drawn, the probability that it's now got n minus 6 apples in the bowl is 1 over 3. Well, what does that mean? If there's n minus 6 apples at the end, what must have happened? Well, we've already worked out that there were n minus 4 apples at the start, and if there's now n minus 6 apples, then 2 apples must have been drawn. In other words, on the probability tree diagram, we've gone down here, and then we've gone down here. And if we do both of those, the probability of both of those things happening is 1/3. So I don't need the whole tree diagram, I just need to know this value here. Well, okay, so let's work that out. If we've started here and we've taken out 1 apple, then how many apples remain in the bowl? Well, it must be n minus 5 out of n minus 1 pieces of fruit. That's straightforward. Oh yeah, just a rewording of the problem there, just to make a bit more sense to us. And I'm filling that probability there. And we're told, yep, the probability that 2 apples are taken is 1/3, so this times this must be 1/3. Okay, great. All the probability is now done. We've turned this whole problem into an algebra problem. We just need to solve this equation. So I don't have much space, so I'm going to start up there in orange by first combining into a single fraction. I saw a lot of candidates trying to get a common denominator, but it's multiplication of fractions. You don't need or want a common denominator when you're multiplying fractions. Just top times top, bottom times bottom. Okay, before I start multiplying things out, I'm going to actually first eradicate the fact that we have fractions at all. Fractions cause problems in equations, so just take steps to get rid of them. We've combined into a single fraction. Now let's multiply by this denominator to move it upstairs on the right. And while we're at it, let's get rid of the 1/3 by multiplying both sides of the equation by 3. Okay, I'm going to now start expanding, but being careful here. I'm just going to leave the 3 where it is for a moment, just expand these 2 brackets together. And the other side I can just expand. And now I can multiply through by 3, although I'm just going to acknowledge that we've got minus 9n there together. So the middle term here is going to be 3 times minus 9n, in other words, minus 27n. And finally, bring it all onto the left-hand side. So it's a simple quadratic equation. I notice I can divide everything by 2, so we'll do that. And now this factorises nicely, minus 10 and minus 3 as in our brackets. And that gives 2 possible answers to this whole problem of 10 and 3. Now, is it both? Nope, because one of them isn't valid. Remember, how many apples did we have to start with? We had n minus 4 apples. And of course, if n is 3, then that's impossible. So n simply must be 10.